C3 functions, inverse functions. To find the inverse of a function, f(x) usually written as f to the power of minus 1x, use the following steps. Step 1. Put the function equal to y. Step 2. Rearrange to give x in terms of y. Step 3. Rewrite as f to the power of minus 1 x, or inverse fx, replacing y by x. Okay, let's have a look at an example of how we find the inverse of a function. Let's take a function. Let fx equal 2x minus 1. X ER. XER means x belongs to a set of real numbers. Okay, if we follow the steps, step 1, replace fx with y, therefore y equals 2x minus 1. Step 2, rearrange to find x in terms of y. So 2x is equal to y plus 1, x is equal to y plus 1 divided by 2. Step 3, rewrite inverse function replacing y by x. Okay, this is now the inverse of the original function, and if we wanted to write it as y, that would be equal to x plus 1 over 2. So this is now the inverse of our original function. Okay, and reminding ourselves the original function that we had was y is equal to 2x minus 1. Sketching the graph of the function and its inverse. Let's remind ourselves of the function that we looked at before. Fx equals 2x minus 1. If we want to draw the graph of this function, replace fx with y, so y equals 2x minus 1. To draw the graph of this equation, we simply need 2 points. So let's take a couple of values of x and find the corresponding values of y. So when x equals 0, y is equal to minus 1. Now let's take a value of x further down the x-axis. So let's take x is equal to 3. If x equals 3, y will equal 2 times 3 minus 1, y equals 5. Now we plot these points on the grid. So remember, it's y, x. So when x equals 0, y equals -1, we have a point here. When x equals 3, y is equal to 5. So we have a point here. Right, okay, to get a more accurate line, we should take another point. So now, when x equals 2, y will equal 2 times 2 minus 1, y is equal to 3. So, putting this point on the grid, when x equals 2, y equals 3, we have a point over here. Now we should connect these 3 points with a straight line. Okay, this is now the graph of the original function, just to highlight the points there. Okay, we want to now compare this with the graph of the inverse of this function. So let's just label this before we move any further. So this is now y is equal to 2x minus 1. Okay, we remind ourselves of the inverse function. The inverse function was fx equals x plus 1 divided by 2. So remember, when we want to draw the graph of this, y will equal x plus 1 divided by 2. So now, in the same way as before, we will need to take a few points and plot them on the grid. So when x equals 0, y will equal a half. When x equals 3, y will equal 3 plus 1 over 2, y equals 2. And to be safe, let's take another point. When x equals 5, y will equal 5 plus 1 divided by 2, y is equal to 3. So now let's plot these points on our grid. So when x equals 0, y is equal to a half. So that would be roughly over here. When x is equal to 3, y is equal to 2. And when x is equal to 5, y is equal to 3. We've got 3 points now. We need to connect them with a straight line to the best of our ability. Here we go. There's our straight line. Okay, what do we notice about these two lines? Well, let's just write the equation of that line down. Y is equal to x plus 1 divided by 2. Now, what you notice here is that this actually looks like lines which are mirror images of each other. But we need to define where the line of reflection is. So, if we draw the line y is equal to x, you will see that these two lines are reflection of each other along the line y is equal to x. So this then is how we can check the inverse function and its graph. The inverse function will be a reflection of the original function along the line y is equal to x.